There is a delay in a few minutes. A few seconds, sorry. There's a delay in a few minutes. A few seconds. Hello, everybody. We are very pleased to welcome you today. Bonjour, Dar Halamal. I am Karl Merck. I am co-director of FARI, AI for the Common Good Institute. We are a joint institute in AI, data, and robotics based in Brussels, focusing on the common good created by two local universities, the Université Libre de Bruxelles and the Vrije Universiteit Brussels. Thank you all for coming today.
I am Laurence Renaud, strategy and EDI collaborator in FARI. We are delighted to organize this event today on preventing bias and discrimination in AI during the weKONEKT week. In recent years, media researchers and governments have become increasingly aware of the fact that AI can lead to discrimination or reinforce bias. This topic is fascinating and complex. What forms do they take, how to address them, what is feasible, and what remains to be done? The goal of this panel is to learn what could be done to prevent them.
Thank you to our amazing lineup of today, Andrés Algaba, postdoctoral researcher at the Data Analytics Laboratory and the Integrated Intelligence Lab at the VUB, Nelly Roekens, legal officer at UNIA, the Interfederal Center for Equal Opportunities here in Belgium, Professor Touba Birkam, professor of sociology at the Vrije Universiteit Brussels, Jan Rokkeman and Upul Bandara from the Erudi company in Canada. So Jan is the Director of Technology and Software Development, and Upul is the machine learning architect.
The technical background will be made by Andrés. Nelly will discuss some necessary legislative and regulatory tools in Belgium and Europe. Touba will make some reflection on ethics, bias, and AI fumigation. And Jan will present how to enhance recruitment by preventing bias and discrimination. A question and answer session will follow, moderated by Andrés and us. We invite you to ask your question in the chat throughout the presentation, and we will ask them at the end during the Q&A.
Thank you very much. And we now give the floor to Andrés Algaba, postdoctoral researcher at the Data Analytics Laboratory at the VUB. The floor is yours, Andrés.
Sorry, I was muted. Okay. So thank you for the introduction. I hope you see my screen. And so indeed, I will give a short technical overview on fairness in artificial intelligence. And let me start by first saying that fairness is a complicated and philosophical concept, which consists of many dimensions, including bias and discrimination. Now, within the field of AI, we are kind of forced to reduce fairness to something measurable because, well, dealing with machine learning, machines expect numerical input and give us numerical output. So something measurable. From a personal fairness point of view, we can actually say that if we have two inputs, for example, a person A and a person B, that we expect that their outcomes are as similar as these persons are. So if two persons are quite similar, we actually expect them to receive the same outcomes from a machine, and vice versa. This seems intuitive and easy enough, but the devil lies in the details, because the difficult questions arise when we try to implement this in practice. Namely, how do we describe a person or an outcome via numeric representation? And if we have done so, how do we actually measure the similarity between them? I will show you in the next few slides that this is quite a difficult task. But to maybe simplify this a bit, we can say that fairness is something task-specific, meaning that we only care about the attributes of a person that are relevant to the outcome. Say that we, for example, want to hire someone for a certain job, then we care about attributes such as loyalty, intelligence, and perseverance. And the outcome can then be defined as how successful will someone be at the job. Note that already at this conceptual level, so we aren't actually modeling, we're just thinking about a problem, but already at this stage, biases can be introduced. Now, namely, by selecting the attributes and the outcomes, we make subjective decisions which can be influenced by our culture, our historical perspective, and so on. Now, you will note that actually these attributes and even the outcome are not directly observable. They are not directly measurable. So we have to use proxy variables to get an idea of how loyal or intelligent or persevere a person is. So we can use for loyalty, for example, on average, how long a person stays with an employer. For intelligence, we can use the highest degree that a person obtained. And for perseverance, we can use a standardized personality test. Now, again, many biases can be introduced at the measurement stage because, well, for each attribute, many possible proxies exist. And we actually select one ourselves as, well, being the modeler. And each of these proxies can have measurement errors, and often they are non-random, meaning that they are systemic. For example, it is well known that some standardized personality tests are actually skewed in favor or not of some particular demographic groups. Now, this is just for the attributes, but also for the outcome. Say that for the job, we use the performance scores of previous employees as an assessment of how well people have done on the job. Well, these performance scores, the thing we actually want to predict, has been given by people in the past. And again, these people might have been biased. And so actually, even the metric that we want to predict may contain bias. And so our model may not even stand a chance to be unbiased because the thing it wants to predict itself is biased. Now, beside the selection and the measurement of the attributes and the outcome, we also have the similarity problem. I've given here a fictional table with the loyalty, intelligence, and perseverance score of person A, B, and C. And it's actually not that easy to say whether person A is more close to person B or C and vice versa. This is, well, a problem with the high dimensionality of the description of a person. We are very similar in some attributes and very different in others. And so it's not easy to say which persons are similar and which ones are not. And the same problem also exists for the outcomes because, well, while the probability of being good at a job might not, well, be that different, the eventual impact on our lives may be, because if only a few people will eventually get the job, the outcome of getting the job, well, this may have a large impact on our life. Now, this was all on personal fairness level, but we can also think about group fairness, because biases do not only exist at the individual level, but also at the group level. Human society is namely full of so-called structural biases, which are the result of demographic disparities. If you again think about the job market, there is often a large skew in the gender distribution between jobs. We have some jobs which are almost entirely male and other jobs which are almost entirely full female. Now, we can look at this state of the world and decide that actually algorithms should help us to make these disparities disappear in the decision-making process. And this is something which is called independence. In the next slide, I will elaborate on this concept. But note that even if we decide that we will not change the state of the world, we will just, our model should reflect the current state of the world, even then we should care and beware for sample size disparity, because as we have less data on minorities, we may actually also make systemically larger or more errors for these groups. Note also when we enter group fairness, from a personal fairness to group fairness, that we actually have to, again, categorize people. And this, again, these making these categories may also introduce, again, biases, because we divide people into groups. Now, independence and separation are two group fairness notions. For example, you have demographic parity with independence, and demographic parity implies that the probability of a positive or negative outcome is equal across all groups, meaning that if we deem 30% of the men fit for a particular job, we should also select 30% of the women fit for a particular job. So we actually want to have the same acceptance rate across these two groups. This is a useful notion if, for example, the performance scores were biased against women in the past. This is unjustified, and we want to correct for that with our algorithm. Another notion is separation, where you have, for example, equalized odds. And this implies that the error rates, namely the false positive and false negatives, are balanced over all groups. This has to do with if we do not want to change the state of the world, but we want our algorithms to be fair from the point of view that they shouldn't be making any more systemic mistakes for particular groups. Now, note that I say that both metrics are useful, and I'm not saying that either one is better than the other. It depends on the application and on the kind of fairness you actually want to achieve. They all have their benefits and shortcomings, and we should, well, make some choices here because there exist some trade-offs. We can not always maximize all notions of fairness. Now, luckily, because I've named quite a few of difficult problems, luckily there are solutions. And I've put here on the top a solution which isn't really one, but most people still think it is. And it's fairness through unawareness, but it's not a solution. In this solution, which it's not, you remove the inputs related to the sensitive information. But this does not work because the remaining inputs still contain a lot of information about the sensitive inputs which you removed in the first place. The point here is that as our models get more powerful, they can actually reconstruct the sensitive information, which we do not want, of course, because then the model can again make decisions based on this sensitive information. But there are some things we can do. And the first thing is pre-processing, where we actually transform the data even before we get to the modeling part, and we actually debias the data itself. Another sometimes more powerful method is in processing. This is during the training of the model. We do not only care about the model's performance, but we also care about the optimization of the fairness metrics, which I discussed in the previous slide. Something which we can also do is post-processing. And the nice thing about this technique is that it's even applicable in black box scenarios. So there are no excuses not to care about fairness, but because even if you don't have any control over the model or how it was trained, you can still apply transformation to the model's outcomes to improve the fairness of the predictions. Now, to end my presentation, I want to say that fairness is a lot broader than what I've presented in this short presentation. And there are also many interesting connections with other research areas, such as the robustness of our models. For example, a small change in the input shouldn't most times cause a large change in the output. We should also care about privacy and domain adaptation and about the explainability of our models or the internal logics, how they are actually working, because explaining can also be a step towards more fair models. So yeah, this was my presentation. Thank you.
Thank you very much, Andres, for this great presentation. And now I will present the next presenter, Nele Roekens. She's a legal officer at UNIA, the Interfederal Center for Equal Opportunities. And she's also a member of the Law and Ethics Board of AI for Belgium. So I will share her presentation and she will be, you can start talking, Nele, and I will present and change the slides for you.
Thank you. Thank you, Carl, for that kind introduction and inviting me to speak at this event. Today, I will talk a little bit more about existing and future legislative instruments and how they can be used to tackle algorithmic discrimination. My name is Nele Hoekens, and I'm a legal counsel at UNIA, as you said, and you also introduced the Interfederal Public Institution. The thing I want to underline is, you can go to the next slide, is that UNIA is member of, is a national human rights institution and an equality body. This is a UN requirement for countries and an EU requirement for member states. And both have networks in Europe. This is important to underline because they identify AI as a priority and pay due attention to algorithmic discrimination. That the use of AI with its specific characteristics, the opacity, the complexity, the dependency on data, autonomous behavior, can adversely affect fundamental rights is widely acknowledged, like Laurent said in the introduction. But why does non-discrimination receive particular attention in this fundamental rights and AI debate? This is because inequalities are rooted in society, and AI systems tend to perpetuate and even reinforce these patterns of injustice. At UNIA, we have 3 main activities, including case handling, and it might interest you that we have already received notifications on algorithmic discrimination, most notably in the housing and labor market. Via policy recommendations based on studies, we try to improve national legislation, and you might expect some action from us in the future. But today, I know that we focus on what is being done in Belgium, but it's imperative to quickly run you through policy and legislative tools on a bigger scale as they operate interdependently. So please go to the next slide. First of all, you see this proliferation of ethical guidelines. All stakeholders, big tech, academia, civil society, lawmakers agree on the importance of principles like transparency, fairness, accountability, privacy, and so on for ethical AI. These guidelines, based on the European Union high-level expert group, their work, lay a common ground for discussion, and at the moment, various actors are in the process of operationalizing these. However, even when they will be fully operational, they remain non-binding, and nor will there be any oversight by public bodies. As such, there are no effective redress possibilities, and they do not suffice to tackle algorithmic discrimination. The second tool that we see on a legislative level, and it is very important in the context of AI, is EU law. EU fundamental rights and regulations, as well as data protection law, are applicable and are already being used in this context. Privacy law does not merely safeguard privacy, it rather fulfills a much broader goal, objective, which is protecting fundamental rights and freedoms. And an interesting case in that regard is the Siri case from the Netherlands. You might already have heard about that one. In this case, the Dutch court considered that Siri, which is a legal tool used by the government to protect combating fraud in areas such as social benefits, violated Article 8 of the European Convention of Human Rights. This is respect for one's private life, because it failed to comply with fundamental data protection principles such as transparency and the principles of purpose and data minimization. So the good news is that we don't completely have to reinvent the wheel, but this legislation that is already existing is not always easily applied due to the transparency issues in AI and the difficult interpretation of the information. Plus, at the moment, we have a lack of standards, how accurate has a system need to be. So there is a crucial need for more specific regulation. So then the question arises whether the long-awaited European Artificial Intelligence Act will suffice. There is a proposal that currently is in the European Parliament, and this proposal introduces some limited bans on some AI systems, and it works with a high-risk classification system, installing transparency requirements for high-risk systems. It does not, contrary to the GDPR legislation, list rights for those affected by AI. As it is still in the European Parliament, it will take some more years before it will be in effect. Good understanding is recommended, though, at this phase, because it will be setting international standards and inspire other legislation. In our opinion, this current proposal and its product approach, it will not suffice nor provide sufficient protection to tackle algorithmic discrimination. So the answer is no. Additional instruments are necessary. And this could be existing or future national laws, but we will come back on that later in the presentation. And lastly, I draw your attention on supra and international initiatives that can also be handy in developing national tools. You can go to the next slide, please. So before that we can come up with the solutions, I will briefly elaborate on some key concepts of equality law. Direct discrimination is clear-cut. And as you can see on the slide, it occurs when you make a distinction based on a protected criterion. But algorithmic discrimination is often more abstract, subtle, and intangible. And a protected criterion will not often be inserted as a variable as such. Luckily, indirect discrimination is a better conceptual fit. It occurs when a seemingly neutral rule or practice disproportionately affects a protected group. It is often the result of counterintuitive proxies that are not covered by GDPR. As such, the notion is fit for addressing discrimination by proxy, like a little bit elaborated on by Andres. But solid knowledge of equality law is required to build a bias-free system. And I try to illustrate this with the example on the slide where I go back to the good employee metric used by Andres. Imagine, for example, that you insert in a system that when an employee is not working full-time, then this employee would not be loyal. This would be this could be an indirect discrimination for persons with a disability. Think, for example, of someone with a chronic illness that cannot work full-time because of its illness, but also for women, because statistically speaking, the women are performing less full-time jobs. So, but data analysts might not always be aware that this could lead to discrimination. So this is really a focus point. And what we also must remember, and the message I'm trying to convey, is that the prohibition of discrimination requires more than a passive refraining from overt unequal treatment. It may also require an active adjustment of an apparently neutral norm. And this requirement applies even more in the case of the protected characteristic of disability, since the duty to provide reasonable accommodation entails a positive obligation and the refusal amounts to discrimination. And we can use the same example there. So together with instruction to discriminate and discriminatory harassment, which are less relevant in this context, these are the 5 classic forms of discrimination addressed in EU directives and national legislation. But as you can see, these relate to discrimination on the basis of one protected criterion and to the carrier of this protected criterion. But due to the high level of differentiation in algorithmic prediction, this poses another conceptual misfit. Luckily, on the next slide, you will see that the last decennia, jurisprudence has accepted 3 additional forms of discrimination. These have been accepted to varying extents, and they operate outside this scope. So first, you have discrimination by association, which occurs when an individual is treated less favorably because of their association with another individual that is the carrier of a protected criterion. So, for example, the European Court of Justice found in the Coleman case that a mother was discriminated at work because of the disability of her son. But in the context of AI, association does not need to be correct. And think, for example, of social media that is identifying and allocating a gender or a sexual orientation to your profile. This might be a wrong identification. In that case, discrimination by attribution might come in handy. This occurs when someone is unjustifiably disadvantaged because of a characteristic that is wrongly attributed to that person. These forms are really interesting, but still address discrimination from the perspective of a single ground. And disparity will occur not only between legally protected groups, it may only occur for carriers of multiple protected grounds. So the unequal treatment will be the result of several grants interacting with each other at the same time in such a way that they are inseparable. For example, a system does not consider being female or being female by proxy as something negative, nor does it consider being religious or religious by proxy as something negative. But when these two proxies are combined, it will result in a negative outcome. And this is called intersectional discrimination. Legally, this is not yet possible under EU law, and hopefully clear guidance will be brought in the coming years. So in conclusion, the new types of AI-driven differentiation may be particularly problematic from this point of view, and they remain outside the scope of traditional equality law. But there are two other key concepts of equality law that I quickly bring under your attention because they might provide some actual tools to tackle discrimination. So usually in law, there is some kind of fault required to establish an infringement. As a society, we deem that reasonable. But non-discrimination holds a special place in our society, and it does not require any kind of fault. It does not matter at all whether a system is designed to discriminate or whether it is a mere side effect. Think, for example, at the French Parcoursup system. This was a system designed for a more equitable allocation of high school places, but the intention did not matter because in the end, the sole result was that it some protected groups and was infringed with privacy and disability rights. And as you probably all know, a major challenge in algorithmic discrimination and a hurdle to effectively combat discrimination with equality law are transparency issues. And an interesting tool provided by equality law in this regard is the shift of the burden of proof. This was already introduced before AI to ensure the effectiveness of this legislation. So usually this requires that you can provide some facts from which discrimination may be presumed. However, in equal pay litigation, it is established that when a system that is lacking total transparency, it can lead to an immediate shift of the burden of proof. And we strongly believe that this principle should also be applied in the context of AI. So after this quick crash course on equality law, we go back to AI. You now know some of the tools. Let's look at the problems. Regarding transparency, I'll give you an example. When a customer's loan is refused, the customer will not necessarily know whether it was an automated decision that made the decision and why the decision is taken. In other words, there is a lack of micro-transparency, the lack of knowledge how algorithms based on a certain input A produce an output B, the process, but also macro-transparency. Is AI used in the decision? This makes effective redress very hard. The other challenges on the slide are widely acknowledged. I also should underline that this is not an exhaustive list, but special attention should be given to number 6. We sometimes believe that tech can solve social issues, and the current paradigm, let the data speak, is naive at best and dangerous at worst. We still need to make policy choices. And let's now take a look at what's being done in Belgium. So there is some legislative attention. For example, last year, there was an amendment proposed to enhance transparency in the public sector. However, the scope is quite limited and societal interests are not taken sufficiently into account. Regarding the policy requirements, apart from the not yet fully operationalized binding ethical guidelines, there are not a lot of concrete policy requirements that I am aware of, but I would gladly hear your insights and learn more about this. The third important thing is a lot of awareness raising that is being done in Belgium. This is being done by think tanks, academia, and coalitions. Like, for example, FARI, Kenniscentrum Data en Maatschappij, and AI for Belgium, where Karel already referred to. And I have no doubt that the work and the awareness raising of these institutions will positively impact on more robust and ethical use of AI. And lastly, as we see already in some neighboring countries, for example, Netherlands, case law could be a useful stimulus in the adoption of legislation and policies. But to my knowledge, there is no Belgian algorithmic discrimination case law. So if you are aware of that, please feel free to let me know as well. And then I think my time is over.
No, you still have 30 seconds, 1 minute if you want to finish.
Okay, then we quickly go to the last slide. Here you can see some suggestions. I should underline that these are also non-exhaustive. So I just warmly invite you that when you have additions, critical questions, creative ideas, feel free to contact me and discuss this. You can find my email address also on the last slide.
If you want, Nelly, you can still have 1 minute to present some of your suggestions more in detail. We are good on time.
Okay, thank you, Carl. So we already discussed the transparency requirements. The development of a national register would be very welcome in that regard. Also, the transparency requires should entail all steps of the software design. We strongly advocate the introduction of the shift of the burden of proof explicitly in law for systems that lack transparency, and amend equality law to include intersectional discrimination, as this is one of the main challenges. Ensure appropriate oversight by public bodies, by, for example, the Data Protection Authority inspectorates, even before the AI Act body will come into play. Train the developers and the users is of utmost importance. And then my last suggestion is introduce prohibitions and develop accuracy standards. And just think about it, when a tool is not fit for a certain purpose, maybe it should not be allowed at all. Thank you for your attention.
Thank you, Nele, for your very insightful presentation. I will now have the pleasure of presenting our esteemed colleague, Tuba Birkan from the Vrije Universiteit Brussels. Professor Tuba Birkan will talk about the ethical challenges also of AI and big data in migration. So the floor is yours, Tuba.
Is my screen on?
Your screen is on. We don't see your presentation yet.
That's bizarre. I'll try it again. Is it now?
We do see it. Yeah, perfectly.
Okay, perfect. Thanks a lot. Ooh, it will be very difficult to talk after the experts because I'm not an AI expert myself. But as Carl said, I'm working in social sciences mostly, but I'm very much interested in the real life implications of AI applications. So I'm going to take you from the algorithms and the legislations to more implementation in real life. And today I'm going to talk about particularly the inequalities in migration due to AI applications. So why do we really care about migration specifically? We do know that discrimination is everywhere. The bias is something to tackle within all areas. However, I think most of you are already familiar with the news that we've been hearing about the Ukrainian tragedy, but not only about it, you will hear a lot of discourse on these refugees are like us. They are blonde. They are relatively civilized. So we do see prejudice and bias more when we are talking about migrants, irregular migrants, and refugees. So the ethnic discrimination comes a bit more visible when we are talking about migration. But of course, we are also talking about different types of biases, but more importantly, ethics. Yes, there are some ways. I know that the scientists are working pretty hard to tackle the existing biases in different areas. However, let me tell you a little bit about what if it is not only on the shoulders of the AI engineers when we are talking about the bias? So big data and artificial intelligence have been used everywhere, also in migration. And why did I put understanding and governing migration? Because we do have two main pillars. On one hand, we do see a lot of efforts from like international institutes, statistical offices, scholars, where they try to improve the statistics about migration. So they try to estimate the how many migrants there are. They are trying to predict and forecast the flows, but they also try to understand the integration of different groups. But on the other hand, we do see very well established technological solutions by nations, by the states, as well as EU and larger unions in terms of border management. But why didn't I say migration management and governing? Because conceptually, they are really different from each other. Governing something does not have the element of prevention. But when we are talking about management, we do know that, especially if we go a bit into the policies, we can also talk about how the migration can be stopped or allowed. So today we are going to talk about how to govern the migration, the process as its own. So we do know that several governments are investing, but we do know that in addition to these changes, because very few people are talking about EU-LISA, which is a new change in the legislation on the EU level, which allows, like merging a lot of data, connecting a lot of things, and talking about a huge, in layman's terms, cloud of data, which brings a lot of political, ethical, and social questions, which are very difficult to answer. When I call it unanswered, I don't mean that people don't want to answer it. They are not very straightforward. And especially when we are talking about this emerging use of big data and artificial intelligence applications, it is not only for Europe, overall the globe, we say that, yes, you can predict population, you can predict migration, but what are you going to do with that information? So in fact, border security and the security becomes very much pronounced when we're also talking about migration. So the data protection and ethical considerations are a little bit different than the biases that we are discussing, because now it is not only about what is going on in our algorithm, but it's also about how the decisions made based on our outputs from the algorithms or decision-making mechanisms affect people. Are they discriminated? Are they treated fairly? Unfortunately, not always. We do know that these new technologies saves a lot of time. They are very efficient, time effective, but also innovative, and they cost less. But on the other hand, like transparency, citizen engagement, and ethics are crucial to have, but very rarely satisfied, or let's say complied. So when we discuss about privacy, data protection, confidentiality, we do see that particularly for migrants, not specifically for irregular migrants or refugees, when we are talking about for all types of migrants, it's extremely important, because migration is not a physical activity where you move across a border. It is also a very complex bureaucratic procedure which allows cross-border papers and documents exchange. So in fact, your information is also mobile. So what are the essential questions? First, legal requirements, confidentiality and the rules of engagement. And secondly, what are the ethical concerns about the use or misuse of these technologies? So the ethics and bias are not limited, as I say, with the application itself. So big data and AI for migration, of course, has some challenges and benefits. So we are not trying to put it as a black sheep. So today I'm going to talk about very briefly about the benefits and challenges, bias in AI and society, the tools that we use at the border, what about the reliability of the technologies and the implications on fundamental rights? So we do know that big data is great. It is big, it's vast amount of information, it's real time. We get simultaneous interactions. We can know about the behaviors because we can detect unobserved behaviors even, and it's on global scale. But at the same time, we do know that especially from the ethics perspective, there are several challenges that we need to overcome. First of all, the big data has biases, but not because of being big. It is also because it reflects human biases a lot. Secondly, data protection and privacy rights, it's a big puzzle to be solved. Despite all the principles we are talking on different levels, the OECD, EU, on the global level, we are still struggling with how to make them operative. And the third, explainability and auditability. I think migration is a perfect case to underline this one. We will come to that. So the AI tools for migration, as I said, like on one hand, we can use it to monitor and to analyze and forecast migration flows and stocks, which means the number of migrants in a specific geographical area. So we can use it for migration measures, but the Frontex uses it for risk analysis. EASO use it for monitoring. Europol Innovation Hub has information. So you may not be very familiar with maybe these agencies, but what you need to know that there are several international agencies who are working closely and sometimes collaboratively to understand the mobility, especially cross-border mobility. So they calculate the risk analysis. This is a lot of speculations can go around because Frontex is one of the institutes that have been criticized a lot in terms of ethics, because these are the border gods, if you call. So, and they are, I wouldn't say that above the law, but they can really find their ways all around the regulations which are valid for others. So what I mean by migration measures, so I can suggest you several articles, but in short, several scholars show that different types of big data, social media data, satellite data, or mobile phone data can be used to predict migration statistics in terms of inflows, outflows, or the existing migrant population. But I would like to discuss very briefly on the graph on the right-hand side. This is a real-life application by the European Space Agency where they utilize satellite data and developed a product. And they say that with this product, the customers are not identified. They can do a lot of things. They can monitor borders, they can monitor conflicts, they can monitor coastal vessels, so on the boats on the Mediterranean, for instance, they can monitor smuggling activities, and they can track detection. So which means like they can really see which routes people take. So on one hand, it's amazing how much we can know just by satellites, but on the other hand, who is the customer here? We have the product, but what are the regulations around it? Who is going to use it for what purposes? And we do know that satellite data is free for everyone, but on the other hand, we have no clue about the process and the algorithms behind. So the artificial intelligence, the AI at the borders, is not something new. A lot of colleagues of mine and several scholars studies identification technologies, smart borders, integrated border management, automated biometric systems, as well as algorithmic profiling. It's not easy for me to separate them totally from each other, especially in the context of migration, but I will try to give you a couple of examples. When we talk about the identification of technologies, what we do is, the goal is security. They're trying to identify mobile and risky people. So here, a huge discourse is about who is the threat. Are we talking about terrorist threats? Are we talking about illegal activities? So this risky is a very vague concept, but it is not I would say, the role of the computer scientists to really define, because they do work on predefined cases. So we know that fingerprints are collected everywhere at the border. When you get a visa, you need to give your fingerprints. So facial recognition have been used at a lot of places to identify people, not only at borders, on the CCTV images in the streets. And automated identification in AI is a kind of combination of all. And you can say that, yeah, but that's great. Like I can really turn on my screen with my fingerprint, but I can use it, so I don't need to, I can just use the facial recognition to make a transfer to the bank. Yes, when you think about this daily activities, it might look like more innocent, but there are some ways where they become more dangerous and threat to different people. I will give you an example which is not relevant to the migration, but I will try to underline why it is important in the case of migration, especially when we are talking about ethnic differences. So we do know that when we talk about African migrants or Middle Eastern migrants, we mostly talk about the regional differences as well. And it is not only about the skin color of skin, but we are also talking about gender. We are talking about the clothing. So this is a study. It's not a very new one, but it's from the Gender Shades Project. And I think it's really nice because it shows how our well-trusted facial recognition technologies might be wrong. So what do they mean by wrong? So here the project evaluated the accuracy of AI. So, and they wanted to see this gender classification. And unfortunately, the results were as discriminative as we human are. So what they found that women, white people were recognized better, and men were recognized better. And this is not because AI is programmed to be in favor of a specific group. It was just because the data that they are trained, the algorithms, and as well as the interpretations were biased too, because we do not collect specific information when we are running our AI algorithms. The training data sets might be biased, and it is not very easy to correct that bias because it is not on purpose collected data sets. So here it's really important to show that when we are talking about smart borders with the facial recognitions, but we are also talking about visa applications, asylum applications, and the interviews with AI algorithms, we have to acknowledge that it might fall short in some aspects. And then the smart borders, I think we are very happy when we are traveling with planes. By planes, we go there. It's way easier when you have your electronic passport. You go there, you smile to the camera for a couple of more minutes because they recognize, but at the end, it's very fast. But on the other hand, it brings all the questions that we have. So if you are in a non-disadvantaged group, your life might be easier when you're going through these processes. But don't forget that when we are talking about smart borders, this facial recognition might lead you having a 3 hours conversation with the police just because you are brunette and wearing a beard. So we do know that these systems are very race and ethnic background sensitive. So it is really important to think that what will be the implications in terms of access to fundamental rights, and what about the risks related to bias, discrimination, and their data protection and mass surveillance. Why do I call it mass surveillance? Is because we are in fact living in a world where we have integrated border management, which means they are bringing everything together. So you have your documents in the population register, you have your information, I don't know, at the embassy, you have your information at the police. So what they do is, through blockchains, they keep all the transactional records in several databases, and they can really link them through several nodes. And this digitalization makes things easier, but on the other hand, it might really cause troubles and unfair treatment. Very brief example, I don't know if you have ever heard, but most of the refugees are obliged to be part of these iron scan applications to get access to food or aid or the basic needs. On one hand, so it's everywhere, like it started in Jordan, but now we hear it in more different countries. So in fact, almost, let's say, we know that more than 80% of the refugees had to give consent, which is extremely important in data protection and privacy. They have to give consent to be able to get food or diapers. So you can argue that when you look at the data, you can tick a lot of boxes about, no, this is fair, we are compliant with the GDPR because there is consent and we are not using the data. But on the other hand, they are not very familiar with what's really going on. So this iris scan technology allows the funding institutes, humanitarian institutes, as well as the migration-related public authorities to get access to all types of information and link everything together. Why does it matter? Why do we really care about this algorithmic profiling? Because another example from out of migration, but it's a very famous one. We do know that, especially in the States, when they predicted the risks okay, when they are profiling criminals in the prisons, they wanted to predict what is the probability for them to commit another crime. And, like they used, of course, the existing databases, and the algorithms work pretty accurate, which means the algorithms work smooth. However, when they checked, when you don't see the people, they found that, like for instance, for this old white guy, he's assigned as a low risk, but this black young boy was as a medium risk. However, when you look at the background, especially the offense backgrounds, it raises a lot of questions. I don't say that this is not being corrected. Yes, people are working on that, but this is way beyond correcting an algorithm, because this is about the bias in the justice system where specific groups are more represented or overrepresented in some cases. So what I'm trying to say is that the algorithmic profiling, especially for the border management and migration, when we are calling someone a threat or a risk, we have to acknowledge that the algorithm going behind is not any better or unbiased than a regular human being. So automated decision-making processes for visa applications, asylum applications, residence applications, or like the in general migration processes, they can easily be misused, if I have to say, to ignore the fundamental rights, because people have right to flee. They are free to move, migrate, or seek asylum, but this might really be an obstacle for them. But it can also exacerbate pre-existing vulnerabilities, because it adds extra risks on biases, but errors, system failure, but there's also theft of data and violation of privacy rights. So I'm not going to go into the technical details. We have the experts here, but we do know that bias is not only in the algorithm. The data can be biased, the algorithm can be biased, but interpretations of the results can also be biased. That's why the human involvement is extremely important, especially if you're talking about an application with huge societal impacts. So AI application usually makes biased decisions. So regarding specific groups, when we are talking about migration, then the question arises, who deserves to be a refugee? Like the one who is like us, or the one who is in need, or it can also propagate gender stereotypes, because we do know that if you are a young male Middle Eastern or African person applying for a visa or an asylum, the acceptance rates are way lower when you compare. So in short, like the stereotypes are already there. I don't say that AI creates them, but it can really, it can really makes them be bigger than they have to be. So biased AI is not a result, but it is linked to the biased society, because we are biased. So when we're talking about the data, the algorithm is just one of the components. We have the user who provides the input. We have the providers who are tackling and wrangling the data, analyzing the data, but we also have the impacted people. So I think if we see the picture as a big whole, then we can really see how important it is to include trust. In addition to, of course, like where most of the things that you see here can be read in several articles, like explainability, agency, like interfaces, embodiment, design by ethics. But we have so many things, and I think being human-centered is extremely important for the criticality of artificial intelligence. So what are the consequences in the case of migration? Real-life implications on real people. So they are facing unequal treatment on different levels. It could be really on the decision of your application. It could be your daily life. They have to bear with the violation of human rights. And I think the most important thing is they can be really prevented from the basic and the fundamental rights that they are, let's say, eligible for. Can we have unbiased and trustworthy AI in general, not only for migration? I think it will not be very easy, I have to say. And first of all, AI literacy, I think Nella also mentioned about it, is very, very crucial, because we are talking about policymakers and decision makers, either in companies or public authorities, who make decisions on the outputs of this AI things or the implementation of those, who really don't know what an AI is, how it works, what are the restrictions, what is possible, what is not, what do we mean by data, what do we mean by error. So it's really important that different stakeholders are trained, or they have at least a minimum level of literacy on data and AI in general. And secondly, I guess it is also important from the developers or the scientists, the researchers side, is that yes, we are working with coding, codes and algorithms. It's very straightforward to, not straightforward maybe, but it's easier to debug a code and make it work. But if you are working on bits of a larger application, it might be easy to lose sight on the human beings behind those algorithms. So it's really important to remind ourselves that these are going to have direct impact on vulnerable people. Transparency, explainability, and interpretability are very important. I think that's the most challenging part, because the AI works more or less like a black box. We know the input, we know the output, but there is no static process going in between so that we can really put in steps. So I know a lot of things are being done on improving the explainability, but I would like to end it with state-industry relations, because not only for migration, but in general, when we are talking about the capacities, we do not have universities who are the research pioneers now, especially in AI. Most of the pioneers are companies, because they do invest a lot, they are global, they can be everywhere, and they are more ambitious. So yes, it really makes faster in terms of everything going faster in terms of technological developments. However, it makes a lot of things very ambiguous, because when states, let's say, subcontracts a company to do a research, it's not very easy to see how the GDPR is really complied. What I mean is that states can be accepted from GDPR if they are doing a governmental research. So in one hand, the responsibilities are not clear, but in the second hand, the accountability is not clear. Like we do know, assume that there is an application on the border which discriminates people. Who is responsible? Is it the developer who developed the algorithm? Is it the country who bought it and put it on the border? Or is it the person who were there? Because like these decisions are usually followed up by other humans. So who is responsible for that? Who is going to take accountability? Because there is no audits there. We cannot audit it. So as a final, I hope I'm still in line with my time. I would like to...
You have 30 seconds.
Okay.
Thank you.
So I would like to end with a question, but my discussions they are not inherently neutral. So these AI systems, we have to start with understanding that thinking that computers and data science is unbiased or more objective than human, it's not correct. But we can correct them easier than human beings. That's the correct part. So we have to really explore how we will work with them. So we are not talking about the future where AI and robots take over everything, but we have to be ready and open for a hybrid environment where we're going to work together in decision making, but also in implementation overall. And like the definitions and the measurement of fairness, as Andres said, it's very difficult. It is multidimensional. It's a very fragmented concept. But I mean, I will put the question on the social part, like, are the facts fair? Okay, so not only the AI or the algorithms, but what about the human beings? Are the decision-making fair? Are the public fair? Most of the cases, no. So I guess this fairness and the measurement of fairness will be also very much important. We need more research, multidisciplinary research, and the different stakeholders together, and particularly for the migration management, we have to say that this face recognition is really problematic, and that's one of the reasons that EU had a step back for that. So we do know that we couldn't manage to correct for the biases and existing challenges, but still some of the applications are ongoing, so it's a very, very important part. And I will end up with a question can unbiased AI exist in a biased society? Thanks a lot.
Thank you very much, Tuba, for this great presentation. And after having seen with all the presenters before the different definitions, real world impact, we are very happy to also look at a different perspective outside of academia with Jan Rockeman and Upul Bandara from the Erudi company in Canada. They will present also their own efforts to try to prevent biases and discrimination and how they handle it in the private sector. So please, in the HR context. So please, Jan or Upul, the floor is yours.
Thank you very much. So let me share my screen.
In the meantime, if you have any questions, please drop them in the chat. For all the people on YouTube as well, please, the chat is also live. Please don't hesitate to share your questions. So sorry, Jan, the floor is yours.
Okay, so I think I will be able now. Do you see my screen?
Not yet. Okay, now it's good.
Excellent. So thank you very much to give us the chance today to speak in this interesting round, this interesting event. So my name is Jan Rockeman, Technical Director at Erudi. I'm here today with my colleague, Upul Bandara, Machine Learning Architect at Erudi. So I will be talking about enhanced recruitment today, which is a kind of an exciting playground for artificial intelligence, but it's also a subject where preventing bias and discrimination is crucial. So I would like to tell you some words about Erudi. So Erudi, it's a HR tech company. It was born from an idea to make people the heart of organizations again. So at Erudi, we are combining HR subject matter expertise with software engineering excellence, artificial intelligence, state of the art, to create products that are built on these three pillars. So, and we recruited a diverse, multidisciplinary team to make it happen. So when it comes to recruitment, there are some key challenges that we are trying to address through technology at Erudi. So recruiters, in the vast majority of cases, are screening a huge numbers of resumes almost daily, or it's really processing a huge amount, and without tool support, it became nearly impossible for global companies or even national companies exposed to a wider audience of candidates. And to make it worse, from the perspective of the recruiters, they recruit often for several open positions simultaneously. So all the feedback they're generating, they have to kind of structure, to document, to be able to act on it, to do feedback evaluation. Fairness of the hiring process, it's a key challenge where recruiters are playing a key role. And of course, avoiding bias and discrimination, it's also one of the key challenges that recruiters contribute to. So at Erudi, we are proposing to using automated recruitment tools to enhance recruiters, to enhance humans. So there are many opportunities in it, as we believe, as other products already proved. But same thing, there are also many risks, and many products are also proving that these risks are real. So when it comes to opportunities, also in the context of avoiding bias, when a recruiter is able to systematically evaluate a bigger candidate pool, the risk for discrimination might go down. We're not letting candidates out when we're looking at the whole pool of candidates. So the bigger the evaluated pool gets, the higher our chances that we're looking at all potentially qualified candidates. So to automatically compare candidates to pertinent job requirements, it's a huge help for recruiters. So highlighting key skills, key accomplishments, comparing that with the key objective in job descriptions, that's something that gives a huge potential to ease recruiter workflows. So the collected structured feedback while using recruitment tools, be it when sourcing, be it when ranking candidates, evaluating candidates, or when preparing feedback to the candidates, is another opportunity to ease the daily pain points of a recruiter. And one huge opportunity for AI in automated recruitment tools is that there might be inherent bias in AI modules and recruitment tools, but it's certainly different from the conscious and unconscious bias that a recruiter might have. So the recommendations by automated tools generally differ from recruiter conscious, unconscious bias. So there are risks to use automated tools. So first of all, recommendations, if they're incorrect, it kind of nullifies the first opportunity to help the recruiter to systematically evaluate a bigger candidate pool. But there's also a risk that the system is too generic. It gives kind of correct recommendation, but they're not aligned with the particularities of a certain job description or a certain selection policy for certain jobs that a recruiter might have. There's also the risk that in the data indigestion process, like processing CVs, getting it into the automated tool, that incomplete interview notes. So there is a risk that the lack of data quality and quantity might introduce some kind of a bias as well into the recruiting decision. And when it comes to AI, in particular machine learning models, there's a risk, a high risk that bias will be introduced. A, by the model design, B, by imbalanced historical data, and as I saw in the previous presentation, the point I'm missing here, it's also by interpretation of the machine learning results. But just wanted to say some words more about machine learning model bias for imbalanced data. So in machine learning, we're learning from historical data. It's in simplified terms, and kind of reproducing the past. And if in the past there were decisions made that reflected bias, discrimination, then machine learning models, if we're not carefully processing the data, will reproduce the error of the past. So there's a huge risk that imbalanced data might bias machine learning models. And another risk, which is kind of state of the art for many recruitment solutions, it's keyword-based searches are applied to filter candidates. And often this is filtering out qualified candidates that use different keywords in their CV, that are trying to to stand out of the crowd by showing their out-of-the-box thinkers. So keyword-based search might filter out this qualified candidates. So at Rudy, with our solutions, we are proposing some risk mitigation concepts for automated recruitment tools. And I think that the most important pillar of our risk mitigation is explainable candidate recommendation. So in the end, we don't just want to give a one score or one ranking without any explanation, and so the recruiter has to trust our solution. We want to explain how did we derive a score, why do we rank candidates for a certain job description the way we do. And in the end, we want to give the recruiter the tools to make an informed decision. It's not our tool who will do the decision, it's the recruiter. Another risk mitigation concept is to create customizable recommendation filters that are adaptable to different selection policies. So for one job, experience might be important. For a different job, matching skills might be important. So we need to give the recruiters the tools to actually adapt the recruitment tool to their needs based on which profile they're trying to recruit. So automated collection of interviewee feedback also one mitigation strategy that I don't see a lot applied in modern recruitment enhancement systems. So recruiters are doing a lot of interviews, but they don't receive a lot of feedback. So collecting this feedback automatically by the recruitment tool, giving the interviewee the opportunity to provide feedbacks that will be stored and made accessible to the recruiter in a structured way. That it's another way to mitigate the risk of recruiter bias, or to eventually correct recruiter bias. Building on the previous slide is data collection, data preparation process that assure that no candidate group is underrepresented. It's crucial for machine learning development to build machine learning models that are not biased. And the human in the loop, it's certainly one of the pillars as well of the risk mitigation and automated recruitment tools. The human needs to stay in control, needs to supervise the AI, and not the other way around. So at Rudy, we are offering a product that it's called Recruitment Platform. So basically this tool, it's about candidate sourcing, finding the right candidates from candidate CV databases, from open web sources like Indeed, LinkedIn, to rank candidates in regard to a certain job opportunity, and to reach out to the candidate, to interview, to evaluate the candidate. So in the scope of this presentation, because it's only 15 minutes, I will only address the candidate ranking part, and I think that's the part where we have a lot of relevance with avoiding bias and discrimination as well. So what we're doing when we do a candidate ranking search, so we're looking at automatically parsed documents. So job descriptions, candidate CVs are unstructured or semi-structured documents, and to ease the recruiter burden, to ease the candidate burden, we're processing those documents to get them into a structured form. So it's a convenience for candidates and recruiters, and also helps us to apply AI to extract relevant features the way we think it matters for the recruitment process. So you see on the left side, you have the structured extraction of applied data scientist job description. You have the desired skills, you have job details. You have also the opportunity to rank category importance, so candidate experience, skills, etc. So nothing is selected there, so it's using default weights. And then given this information, we're able to do a semantic similarity search. And there on the right side, you see two candidates. You'll see one candidate with a 100 score, which is not the unique score, as you will see later. You see this person, it's a lead level at his career compared to the second candidate who is at senior level. And it's relevant for this particular job description. So you see the extraction of skills. You see the extractions of a position summary. You see also that the skills are not exactly matching. That's because we are not doing a keyword comparison, but we are doing semantic similarity comparison on many levels. So in this case, for skill comparisons, we're looking at synonyms, synonym maps. That's a technology we're using. We're looking at on job ontologies to calculate distance between similar skill concepts. So it goes way beyond a common keyword search. When it comes to explainability, so the hypothetical candidate has a score of 100%. So our system gives the opportunity to ask, why is it like that? And you see here in natural language, it's rendered. The candidate matches all the experience, skills, etc. requirements, and so we have an explanation. And we have also a score feedback mechanism. So you're seeing here in seniority, experience, education, or 100%. But the recruiter has opportunity here to adapt, to correct what the system sent, and so the system will eventually learn from this corrections of recruiters as well. And the recruiter is able to give feedback to for the offline AI team to evaluate.
Sorry, sorry, we have 1 minute left.
Okay, 1 minute left. Okay. So more details are rendered with the CV as ground truth, with skills, complete skill extraction. We have for certain job categories, we have additional modules for explainable components like a GitHub analysis. So this candidate has a top 5 of language programming language commits. So algorithmic concepts and methods that we're using. So we're doing parsing of a resume and job description. We do ontology-based job description enrichment. So in many cases, job descriptions are not complete, preventing the fair comparison to a candidate CV. So we're enriching those automatically. We're using feature extraction, semantic similarity, also natural language understanding. And to be more detailed, we use supervised machine learning techniques, fine-tuned pre-trained language models with attention-based transformers like BERT, job ontology, reasoning, distance in ontologies, statistical measures for keyword extraction, word-to-vec clustering. And so kind of nearly concludes my presentation. So going forward, so Rudy is aware that bias awareness and avoiding discrimination in AI has become a highly active research field, very dynamic. Bias awareness, avoiding discrimination, it's also crucial, highly relevant, and necessary in the context of automated recruitment solutions. And Rudy is committed to fair and non-discriminatory recruitment practice as a HR product company and also in our own recruitment practices. So, and this commitment is really part of everything that we're doing: company strategy, product roadmaps, hiring practice, industry partnership, and also our research collaboration. So given this highly active research field, we cannot do it alone. We do it in collaboration with our partners, Polytechnic of Montreal, HEC Montreal, using the MITEX program, having pertinent internships dedicated to bias awareness, avoiding discrimination. So that being said, thank you very much for your attention.
Thank you very much. It was really great to have different perspectives on this topic. So now the floor is to all the panelists. There will be moderated discussion by our friend Andres. So Andres, the floor is yours.
Okay, thank you. Yes, we indeed had a diverse set of interdisciplinary presentations, and we've had quite a few interesting questions. So we only have 10 minutes left, so it may be that we actually go 5 or 10 minutes over time. If you're interested, please stay. And the first question was actually whether fairness AI is only about bias. And the person also asked, what about noise? So the variance in the outcome based on the same input. So maybe here a reply from me, and then the other panelists can join the discussion, of course. So from my perspective, fairness AI deals mostly with bias and mostly today about a group fairness perspective. So we mostly care today about the group perspective, so that several groups, often defined even binary, like gender or race or some other protector attribute, that we have some equality of outcome or at least equality of treatment across these groups. Now, we do care a little bit about the noise, but the thing about most models is that they are deterministic or consistent. If you give the same input to a model, you should always expect the same output. So this is something that most models have. Something else which lies quite closely to this, and also to personal fairness, and also this is an ongoing research, is that if you have small tweaks on the input, it may be that your outcome has some large changes, but this has to do with robustness and also adversarial learning. So also in my last slide, I said that, well, fairness doesn't stand alone as a research field. While fairness mostly focuses on bias, a lot of fields are actually related. So explainability, robustness, adversarial learning, where you actually want to focus more on the noise in the input and stuff like that. So I don't know whether other panelists have to say something about this particular question.
I think that was very complete. Thank you. I do not have anything to add.
Maybe I may add one more sentence what you said, Andres. I think it's important to keep in mind that bias is a mathematical concept, but fairness is a social construct. So when we are talking about fairness, it's not only about having an accurate way. Of course, the errors, the noises, the biases are there, but it doesn't have a uniform definition. So broadly speaking, we just assume that the tools, the software, the AI algorithms that we have are treating everyone equally. So it is not the right definition, but that's the closest one. So I think it's not possible to talk about fairness without bias, but like they are linked, but they are not exactly the same thing.
Yes, I agree with that. And I also think it was a nice perspective in your presentation that even beyond, when you obtain a model output, you don't necessarily have to always act on the output. You always have a human who can take this output and then see whether it's even ethical to use this output in a certain context. So yes, so there indeed, I would say that indeed, fairness AI only focuses on the algorithm, whereas fairness and bias and discrimination, all these large concepts, mainly focus on the whole, on the process as a whole. So yeah, there I agree with. Maybe related to this, and a question I think for Nele was, so It's quite a long question. I'm going to read it out loud and then summarize it. So privacy and ethical considerations are important when using big data AI in migration management and social issues. Then I assume a legal framework is required to address the privacy ethical challenges when using and addressing big data AI. The question is to what extent this legal framework is realistic and practical when dealing with various social culture aspects. So is it possible to define a flawless legal framework to deal with different ground conditions? And if not, what are the trade-offs between keeping privacy and using data? Thanks in advance. So this is also for Tuba, but I maybe want to generalize this question a little bit. In what sense is it indeed realistic in the fast, because also Tuba mentioned that most of the research today, or the state-of-the-art research, isn't only done in universities, it's also done within companies. And how do we make sure that our legal framework keeps up with the state-of-the-art that is done mostly in private companies, which we do not always have access to, because they, of course, choose what they open source. So I'm not sure whether it's a clear question, Nela, or... So we have fast-changing AI. How do we keep up with our legal framework?
Definitely a good question. That's also a little bit the message I try to convey in my presentation, is that we don't completely have to reinvent the wheel, but we must try to use existing tools in an evolutive way. Like, for example, if you think back, when first legislation said prohibited theft, it said it's prohibited to steal goods. But then when electricity and running water was there, this law did not apply anymore. So we have I strongly believe in an evolutive interpretation of the existing law. And that's what I also was a little bit proposing, but this will definitely not suffice in this context. I interpreted this question also really as regarding to migration management, which is very specific. And there, of course, for a suitable legal framework, I have to refer to the ban on remote biometric identification, which is not complete, and there is actually a lot of criticism on this ban. It's very narrow, it's only to law enforcement, and it's very technical. And even in the EU Council, they're proposing several amendments to this provision. So do I think that the legal framework will be completely suitable? I don't see that in a really short future happening. But it's good that the awareness is growing, and the trade-offs is definitely something that we should discuss. Tuba also mentioned it earlier in her presentation. You cannot guarantee that it's non-discriminatory. It completely respects privacy concerns. For example, think of algorithmic discrimination for disability rights, etc. But these are really ethical concerns, in my opinion, as underlined by Tuba. And we should think as a society how do we want to structure our society? So I don't know if that answer was a little bit clear, but I think that Tuba can definitely give some great additions.
Yeah, if I can pick up what Nela just said, yeah, definitely. I mean, I think you answered it pretty well. What I can add extra is that I think it's not specific to migration to start with, and it's not specific to AI. It's all about the digital rights, because this is something new. And it is evolving faster than we do. So, but I think it's not something totally new, because when we had the human rights and since the convention, a lot of things changed. The right violations also changed, and it tries to catch up. I think if we agree on the concepts, the conceptual stability will help us to be dynamic in terms of addressing what is coming next. And very personal opinion, I don't think that we will have a complete, like fully smooth legislation, but we can have an operative one. I think we should go step by step, and it's feasible to handle it, I'd say.
Okay, thank you. And maybe to turn it around, Jan, because, well, they're working on new laws to make AI more ethical. unbias it. Are you actually currently working towards already adapting the product? Because you said that you already in Rudy have some explainability layer. Are you also actively working on improving on the explainability, improving on the biasing and all of that to comply with future regulations?
I think it's not only about compliance. For Rudy, it's an important. Ideally, we would like to have a competitive advantage when it comes to bias awareness, bias discrimination. So it's not only about compliance; it's being at the vanguard. So what you saw today, it's a start, and we are investing heavily to improve bias awareness. So currently, we have a research project with the Polytechnic of Montreal for a bias-aware dashboard to extend what you saw today with a really focused view with the idea to create bias awareness in the goal to avoid bias. And we are also currently in negotiation to get partnership with a PhD program, also with the Polytechnic of Montreal, to use AI more in a technical way to mitigate bias or to ideally avoid bias. Yes, so from our perspective, it's not only about compliance. It's something that we believe it's necessary. We know it's necessary, and we believe also eventually it will become a competitive advantage for us as a company.
Yeah, it's nice to hear, because it's also something which I wrote down, that I see actually that most companies are aware of bias and, well, sometimes unethical behavior of their models, and that they actually see it as a selling point to actively work on this, not only to comply by law, but it's actually a selling point to make models fair. Maybe a question which just got asked, which I think is a little bit related to this again, at the intersection of AI, the research, and AI, the legal framework. So are there any specific bias measures currently mentioned in ongoing legislation which companies can actually use because they have the burden of proof? So how can actually today a company prove that they actually use unbiased models? Because there are also a lot of there are already a lot of metrics within the research that that indicate like how unbiased the model is, but actually there again you can kind of trick some metrics into believing that your model is unbiased while it is not. And again, this is how will legislation keep up with this? Are there already metrics defined, or are companies allowed to just give any metric which they want to just show, well, according to our metrics, our models are unbiased?
I see in the chat it's addressed to me, but I don't know if I'm best placed to answer it. It is actually an excellent question. To my knowledge, it's not in the AI Act as such. It might be in some of the annexes, but I'm not sure, unless maybe you can comment on it. But I guess this will be part of the future discussions and will be the more technical debate on how do we qualify what AI system in what high risk category or risk category in general. So I don't know. I don't think so. So it really depends on if you now would be in court, like arms inequality, etc., who is be able to prove it. But excellent question, and I will surely be checking up on that.
Maybe I will be switching the question to Jan, but with some additional comment. Like, we see that in literature, there's a distinction between personal fairness, which I think legislation today mostly focuses on, but correct me if I'm wrong, versus group fairness. And I have a feeling that research-wise, there has been a greater emphasis on group fairness. So Jan, today, are you mostly checking for group fairness or personal fairness? And what type of metrics do you use today within Rudy?
I think that's kind of a problem when it comes to legislation, because the fairness and measures when using AI models, it depends heavily on use case. It depends heavily on the context. It depends heavily on the available data, also when we're talking about machine learning. So, so the best thing from my perspective so far we can do it's really to define fairness measure case by case for every model, fairness goals. I'm not a legislator, but I think that would be pretty tough to model fairness into laws that apply to all AI models. So.
I fully agree. Maybe Tuba, do you have something to add here? Because this is the last question we'll be dealing with.
Yeah, no, I mean, I'm not an expert in the legislation part, so I leave the floor to the experts. So I don't have anything else to add.
Okay, thanks. Yeah, so I believe this was the last question. We're 5 minutes over time. Sorry that we couldn't answer or reply to all the questions, but I would say, and I believe I may speak for everyone, feel free to reach out. It's an important topic, and well, we're happy to talk about it, not only today, but also in the coming weeks or months.
Thank you, Andres. We hope you enjoyed the presentation as much as we do. Thank you again to our speakers. And we invite you to the FARI conference, which will take place on 5 and 6 July at Beaux-Arts. You can find all the information on our website. So thank you and have a good evening.